Welcome back to Spratt STEM Academy, where we make and keep STEM easy. In this video, we're going to do some exponent rule practice. Before we begin, make sure you're familiar with the 8 exponent rules. I'll link the video to my explanation of them in the description below. We'll start with some examples for product rule. For our first example, we have x to the third times x to the sixth. How are we going to solve this problem? Well, we know that we have the same base x for both terms, so we can use product rule to combine the exponents 3 and 6. Therefore, we can simplify this with just writing x and then combining our exponents to give us x to the 9th power. For our second example, we have base 2 for both terms, meaning that we can combine our exponents once again, 4 and 5. So we're going to write 2 to the 4 plus 5 power, which combines to 2 to the 9th power. Now let's do an example showcasing quotient rule. Our first example is 5 to the 7th power divided by 5 to the 2nd power. Here we have a base 5, and we can take our exponents and subtract them. Remember, top minus bottom. Therefore, we simplify this to 5 to the 5th power. For our second example, we have base 20, and we have to read from left to right when we're using our exponents. So it would be 3 minus 4. We can then simplify this to 20 to the negative 1 power. There's another way to write this. If you remember our negative exponent rule, we can write this as 1 over 20 to the 1st power. For our first example, we have exponents 4 and 8, and since they're separated by a parenthesis, we simply multiply them together. 2 to the 32 power is the correct answer. For our second problem, we have base 4. We're going to do the same thing. Multiply our exponents 1/2 times 6. And to the side, I'm going to multiply out 1/2 times 6. We do cross canceling. We get that 1/2 times 6 equals 3. Therefore, our simplification is 4 to the 3rd power. In our first example, we have 5 times 4 in parentheses being raised to the 5th power. Remember that each term is to the 1st power, so we can just simply write these as 1. Then distribute our exponent 5 to each one, thus giving 5 to the 5th power times 4 to the 5th power. And this would be the simplification. For the second problem, I repeated the steps we used for the first problem and simply wrote x to the 1st times y to the 1st, distributed our 3 exponent to each, which when we write it out gives us x to the 3rd times y to the 3rd. In our top example, we have x over y to the 4th power. Remember that the exponent on each variable is 1 since there is no written variable. Then distribute the 4 exponent to each. Then we can simplify this to x to the 4th over y to the 4th. Here we have 2 to the 6th power divided by 8 to the 6th power. It's written a little differently than our top example. In this example, instead of distributing an exponent, since the top and bottom variables already have an exponent, we're able to do something a little different. Since our exponents are the same, we can simply write 2 over 8 to the 6th power. We can then simplify this further by looking at our fraction inside the parentheses. This simplifies to 1/4. Therefore, we have 1/4 in parentheses raised to the 6th power. Here we have 100y to the 0th power. Now we know that anything to the 0th power is 1, therefore the answer to this would be 1. Same for our bottom example. We have 5x to the 0th power. The rule still applies, therefore the answer is also 1. Now here we have 4 to the negative 2. Now, since we have a negative exponent, we can simply rewrite this as 1 divided by 4 to the 2nd power. And remember, our exponent is now positive thanks to the negative exponent rule. We can further simplify this to 1 over 16 since 4 to the 2nd power is 16. Now we have x to the negative y. The rule still applies. We rewrite this as 1 divided by x to the positive y power. And that's all the simplification we can do for this one. For our first example, we have 4 to the 1/2. Remember when you have a fractional exponent that the numerator is going to be the exponent of the base variable that goes inside of the square root. The denominator is going to be the number that goes in the crevice of the square root. Now using our formatted rule, write our square root, take our base, which is 4, and then write its exponent, which is going to be the 1 from the numerator of the exponent, and the 2 goes on this crevice of the root. Then we can write this as a square root of 4. Whenever you see the 2 in the crevice of the root, it just simply means square root. We can then simplify the square root of 4 to 2. Let's do the same thing with x to the 3/4 power. We write our square root. Our base goes in the square root, which is x. Its exponent is going to be the numerator, so it's going to be 3. Then on the outside of the square root, we put the 4. For our final example, we have 8 to the 2/3 power. We're going to do the same thing here. Our base is 8, so we're going to put 8 inside of our square root. Its exponent is going to be 2, and the outside of the square root is going to have a 3. We can further simplify this by doing 8 squared, which is 64. And we can even further simplify this by taking a closer look at our problem. The 3 on the crevice of the square root is simply asking us what number multiplied by itself 3 times will give us 64. The answer to this is 4, since 4 times 4 times 4 is indeed 64. And that is how we would simplify 8 to the 2/3 power to its most simple form. Thank you all so much for watching this video. If it helped, give it a like, comment, and subscribe for more.